Good morning, dear students. We continue with the chapter Perimeter and Area. Today we begin Perimeter and Area, part 16. We continue with exercise 11.4, page number 227. Main question 10. I repeat again, exercise 11.4, page number 227. Main question 10. Let's go to the 10th question. 10th question, find the area of the shaded portion. Now here, diagram is given in your textbook and we have to find the area of this shaded portion. Now we should first know the area of this main rectangle. The area of this main rectangle can be calculated by knowing the length and the breadth. What is the length of this rectangle? The length of this rectangle is 18 centimeter. The length of this rectangle is 18 centimeter. The breadth of this rectangle is 10 centimeter. So to find the area of this rectangle, we can just multiply the length into breadth, that is 18 into 10. Our answer will be 180 centimeter square. Area of the rectangle is length into breadth, that is 18 into 10, that is 180 centimeter square. But before we do that, we need to copy the details which are given. So rectangle, what is the name of the rectangle? That is rectangle ABCD, or we can say quadrilateral ABCD. This square symbol, we will read it as quadrilateral. The square symbol means quadrilateral. Quadrilateral is a polygon which has 4 sides. A rectangle has 4 sides. So this is the mathematical symbol used for a quadrilateral or any shape which has 4 sides. That shape is represented by this square symbol. So this is read as quadrilateral ABCD. And this symbol is read as triangle EAF. So this symbol is triangle for triangle EAF. So instead of writing the spellings, many times in maths we write the mathematical symbols. So please remember, when a rectangle, square, rhombus, parallelogram is used, we normally use this square symbol which has 4 sides. Any shape which has 4 sides will use this symbol, which is the symbol of quadrilateral. So what is the name of this shape? Quadrilateral ABCD. ABCD. Quadrilateral ABCD, it has length 18 centimeter and breadth 10 centimeter. So 18 is the length and 10 centimeter is the breadth. So that detail we have to write down. Similarly, we are getting 2 triangles in this diagram. First triangle is triangle EAF and triangle EBC, where I have written the base AF as 6 centimeter and the height AE as 10 centimeter. In the second triangle, I have written base BC as 10 centimeter and height EB as 8 centimeter. So in order to find the area of these 2 triangles, the minimum details have to be first noted down, and then only we will start the calculation of the area of both the triangles and the area of the rectangle. First we will calculate the area of the rectangle, that is length into breadth, 18 into 10, that is 180 centimeter square. Since the unit is given in centimeter, we will write the degree 2 because we are writing the answer for the topic area. So whenever area is there, we have to write the degree or power 2 behind the unit. So centimeter square, 180 centimeter square. Now there are 2 triangles in this diagram. Which are the 2 triangles? Triangle AEF. This is the first triangle, AEF, and the second triangle is EBC. EBC. So again I am naming this triangle EAF, or in this direction also we can name it. We will name it in both the direction, that is EAF is the first triangle and the triangle EBC is the second triangle. Now for calculating the area of the triangle, we need the base and the height. So we will take one of this distance as the base and the second distance as the height. Now what children we have to remember is, the base and the height should always form a 90-degree angle between each other. So if we take AE as the base, then the length of the base AE will be 10 centimeter. And if we take AF as the height, then its length will be 6 centimeter. So we will take AE as the base 10 centimeter and AF as the height, that is 6 centimeter. Or we can take the other way around. We can take AF as the base, that is 6 centimeter as the base, and we can take AE as the height, and that will be 10 centimeter. We can take either of this as the base and either of this as the height. So here in this particular sum, we have taken AF as the base, that is 6 centimeter, and AE as the height, that is 10 centimeter. So we need the height and the base for calculating the area of triangle. Area of triangle EAF is equal to base into height upon 2, AF into AE upon 2, where base is AF, the base is AF and height is AE. So we will multiply 6 into 10 by substituting the value of AF as 6 and AE as 10, and we'll multiply 6 into 10, we'll get 60 upon 2. The next step, the answer will be 30 upon 1 or only 30. 6 tens are 60. And 60 upon 2 we have to write. 60 upon 2 we can cancel and simplify and reduce with 2 stable. 2 ones are 2 60s are. 60 upon 2 means 2 ones are 2 30s are. 60 upon 2 can be further simplified as 2 ones are 2 30s are. 30 upon 1 or only 30 is our answer. So area of triangle EAF is equal to 30 centimeter square. So this triangle has an area of 30 centimeter square. Similarly, triangle EBC we have to find out. The area of triangle EBC can be found out by multiplying the base into height and then dividing by 2. Here we'll take the base BC as the base. That is of 10 centimeter. Base is BC, that is 10 centimeter, and the height will take as EB, which is 8 centimeter. We have to remember that the base and the height should always form a 90-degree angle with each other. Since a rectangle, the 4 vertices are a 90-degree angle. So EB we can take as the base and BC as the height, or we can take BC as the base and EB as the height. So in this particular sum, we have taken for triangle EBC base as BC, which is 10 centimeter, and height as EB, which is 8 centimeter. And then we'll calculate the area of this triangle. Area of triangle EBC is equal to base into height whole upon 2, where base is BC and its measurement is 10, and the height is EB, its measurement is 8. We have to multiply 10 into 8 and divide by 2. Our answer will be 80 upon 2. 80 upon 2 can be further simplified as 40 upon 1. With 2 stable we can cancel 2 also, and with 2 stable we can cancel 80. 80 upon 2 means 2 ones are 2 40s are. 40 upon 1 will be our answer, or only 40 is our final answer. So instead of writing as 40 upon 1, we'll write the final answer as a simple number 40. And the area is written in centimeter square or meter square. So here area of triangle EBC is equal to 40 centimeter square. So the first triangle is 30 centimeter square and the second triangle is 40 centimeter square. And the area of the whole rectangle we already know, that is 180 centimeter square. So from 180 centimeter square, which is the area of the whole rectangle, if we subtract this triangle AEF or EAF and we subtract triangle EBC, these two triangles if we subtract from the whole rectangle, we'll get the shaded region, that is the shape known as CDFE. This green colored shaded region, we have to find the area of this green colored region. So to find the area of this green colored region, we have to subtract the two triangles from the whole rectangle. So area of shaded region is equal to area of quadrilateral ABCD, that is the whole rectangle's area. From that we have to subtract this triangle, that is EAF, we have to subtract, and we have to further subtract the other triangle, that is triangle EBC, minus area of triangle EBC. So we'll write down the formula. Area of shaded region is equal to area of quadrilateral ABCD minus area of triangle EAF minus area of triangle EBC, that is 180 minus 30 minus 40. Area of quadrilateral ABCD, that is the area of the whole rectangle, is 180. Area of the first triangle, that is EAF, this triangle's area is 30. And area of triangle EBC, the second triangle, its area is 40. 180 minus 30 minus 40 means we have to say 180 minus 70. 30 and 40 we have to do total, because minus 30 minus 40, our answer will be minus 70. Same sign, total. So 30 is negative, 40 is negative, that means we have to do total. 30 and 40's total is 70. Minus 30 minus 40, our answer will be minus 70. So we have to do 180 minus 70. 180 minus 70, our answer will be 110 centimeter square. 180 minus 70, our answer will be 110 centimeter square, and this will be the area of the shaded region. So answer statement will write, therefore area of shaded region is 110 centimeter square. Main question 10, sub question 2. Find the area of the shaded portion. In the adjoining figure, the shaded portion is given and we have to find the area of this shaded portion. Now this is a square. The name of the square is PQRS. So here we have written it as a symbolic form. For square quadrilateral PQRS, the length is 20 centimeter. The length of the square is 20 centimeter. The breadth of the square is 20 centimeter. In a square, the length and the breadth will be same. So we'll write only the length, that is length is equal to 20 centimeter. Breadth we will not write because it is understood that in a square, the length and the breadth is same. Length is equal to 20 centimeter. So this square is of 20 centimeter. So first we'll find the area of this square. To find the area of this square, we have to just multiply the length into length. Area of square is equal to length into length or L into L, where the value of L is 20 centimeter, or we can say L means length and the length is 20 centimeter. L into L, our answer will be 20 multiplied by 20. The answer is 400 because 2 2s are 4 and 10 10s are 100. So 20 multiplied by 20, our answer will be 400 centimeter square. Whenever area topic is there in the unit, we have to write square centimeter or square meter because the power or the degree 2 has to be written in the unit. So here raised to 2 or the power or degree 2 we will write in centimeter whenever we write the unit for area. Now for finding the area of the shaded region, first we have to find the area of these 3 triangles. Those 3 white colored triangles, if we find and we subtract it from the square area, then we'll get the remaining area, that is the shaded area. So first we'll find the area of these 3 triangles, that is the 3 white triangles. The first triangle is triangle QP T. So this is the first triangle, triangle QPT. So the details for triangle QPT I have written here. First we need the base and the height in order to find the area of triangle, and then if we divide by 2, then very easily we can find the area of the triangle. So the base will take as PT, which is 10 centimeter, and the height will take it as PQ, which is 20 centimeter. Now we have to remember, whenever the 2 sides of a triangle are given and if they form 90 degree, then one of them can be taken as the base and the other can be taken as the height. So here PQ can be taken as the base and PT can be taken as the height, or we can take PT as the base and PQ as the height, because the angle formed between these 2 sides is 90 degree. In a square, we know that the vertices are of 90 degree. So for this triangle, triangle QPT, angle P is 90 degree. Since angle P is 90 degree, we can take PT as the base and PQ as the height, or we can take PQ as the height and PT as the base. For a triangle, if any one side is taken as the base, the other side which is taken as the height should always form 90 degree angle with the base. The height should always form 90 degree with the angle, or we can say the altitude should form 90 degree angle with the side or the base. So here PQ will take as the height, that is 20 centimeter, and base PT as 10 centimeter. Similarly, we have to also find out the base and the height for the other triangle. The other triangle is TSU. Now for triangle TSU, that is this white triangle, we will take SU as the base. SU as the base, so that will be 10 centimeter, and ST will take as the height, and it is of 10 centimeter. Here too, ST and SU form 90 degree angle, so SU can be taken as the base, and the side which forms 90 degree with one of the base, that side will be known as the height. So here ST will be the height, and that is 10 centimeter, and SU will take as the base. Similarly, we'll go to the third triangle. The third triangle, we'll name it as triangle QRU. This white triangle QRU is also a right angled triangle. We are having 3 right angled triangle. This triangle QPT is a right angled triangle because the vertex P is 90 degrees. So in this triangle QPT, angle P is 90 degree. Similarly, for triangle TSU, angle S is 90 degree. So triangle TSU is a right angled triangle. Similarly, triangle QRU is a right angled triangle because the vertex R is 90 degree. So for triangle QRU, angle R is also 90 degree. So if there is a 90 degree triangle, then one of the sides will form the base and the other side will form the height. So here we will take RU as the base RU, that will be 10 centimeter, and the height QR is 20 centimeter. Now here, how did we get here 10? Because it is mentioned very clearly in the diagram that U is the midpoint, and they have given in the diagram that the distance SU is 10 and UR is 10. So that means we can assume that U is the midpoint of line segment SR. So these are equal distance. SU is 10 and UR is 10 because it's already given in the diagram. Similarly, we can assume T as the midpoint of line segment PS because it is given that PT is 10 centimeter and TS is 10 centimeter. In the diagram in the textbook, this distance PT is given as 10 centimeter and this distance TS is given as 10 centimeter. So we can say T is the midpoint of line segment PS. Now we can very easily calculate the area of these three triangles, that is this first triangle, second triangle and the third triangle. So we'll use the formula for finding area of triangle QPT as base into height upon 2. For triangle QPT, the base is PT. For triangle QPT, the base is PT and height is PQ. So that will substitute the value as 10 into 20 because we have already taken the base PT as 10 centimeter and height PQ as 20 centimeter because it's already given in the detailed information given in the textbook. So 10 into 20 upon 2, our answer will be 200 upon 2 and 200 upon 2 means 200's half, 200's half is 100. 200's half is 100, or we can say 200 upon 2 means with 2 stable we can cut the denominator 2 and with 2 stable we can cut the numerator 200. 200 upon 2 means 2 ones are 2 hundreds are 100 upon 1 will be our answer, or we can say the final answer is only 100. So area of this triangle QPT is 100 centimeter square. So this first triangle QPT has an area of 100 centimeter square. Similarly, we'll find the area of the second triangle. The second triangle is TSU. To find the area of the second triangle TSU, we'll use the same formula for the area of triangle, that is base into height upon 2, where base is SU and height is ST. Base is SU, that is 10 centimeter, height is ST, that is 10 centimeter. So we'll multiply 10 into 10 upon 2 after substituting the value of SU. SU's value is 10 centimeter, so we'll substitute 10 instead of SU, and ST is 10 centimeter, so we'll substitute the value 10 and then we'll multiply 10 into 10 upon 2. 10 tens are 100, 100 upon 2, our answer will be 50. 100 upon 2 means 100's half, 100 divided by 2 means 100's half, 100 upon 2 means 100 divided by 2. 100's half is 50, or we can say 100 upon 2 can be simplified or reduced by using 2's table to cut the denominator 2 and using 2's table to cut the numerator 100. 100 upon 2 we can simplify as 2 ones are 2 50s are. Our answer will be 50 upon 1, or we can say only 50. So our final answer will be 50 centimeter square. Whenever area topic is given, we have to write the unit as meter square or centimeter square. So this power or degree 2 we have to write after the unit. So here centimeter is the unit, so we have to write the degree 2. So area of triangle TSU is equal to 50 centimeter square. So we can say this second triangle is of 50 centimeter square. The first triangle, that is this white triangle, is 100 centimeter square. The second triangle TSU is 50 centimeter square. Now we will find the third triangle. The third triangle, that is triangle QRU. This is the third triangle, and to find the area of this triangle we have to use the formula base into height upon 2. That means base is RU and height is QR. Base is RU, that is 10 centimeter, and height is QR, that is 20 centimeter. So we'll substitute the value of RU, that is the base, as 10 centimeter. We'll substitute the height QR as 20 centimeter. So we have to multiply 10 into 20 upon 2. Our answer will be 200 upon 2. 10 into 20, 200. 200 upon 2 means 200 divided by 2. 200 divided by 2, our answer will be 100. Or we can say 200 upon 2 can be simplified and reduced by using 2's table to cut the denominator 2 and to cancel the denominator 200. So 200 upon 2, our answer will be 2 ones are 2 hundreds are. So we will get the next step as 100 upon 1 or only 100. Or we can say 200 upon 2 means 200's half is 100. So 100 centimeter square is the area of triangle QRU. Here also let me remind you children, whenever the area topic is there, we have to write the power or degree 2 next to the unit. So your centimeter is the unit, so we have to write centimeter square. If meter is the unit, then we have to write meter square. So area of triangle QRU is 100 centimeter square. So this third triangle is 100 centimeter square. Now we have got the area of these three triangles. The first triangle, that is triangle QPT, is 100 centimeter. The second triangle TSU is 50 centimeter, and the third triangle QRU is 100 centimeter. So we are getting 100 centimeter, 50 centimeter and 100 centimeter. So these three triangles, if we subtract from the total area of the square, what is the total area of the square? The total area of the square is 400 centimeter square. The area of the square is 400 centimeter square. So from 400 centimeter square, we have to subtract the first triangle 100, the second triangle of 50 centimeter square and the third triangle of 100 centimeter square. Again I repeat, to find the area of this shaded region, we have to subtract the area of this first triangle, which is 100 centimeter square, and then we have to subtract the area of this second triangle, which is 50 centimeter square, and then we have to subtract the area of this third triangle, which is 100 centimeter square. So we will get 400 minus 100 minus 50 minus 100. 400 is the area of the square. 400 is the area of the square. And 100 is the area of the first triangle QPT, that is 100. And the second triangle area is 50. Second triangle is triangle TSU, that's area is 50. And the third triangle QRU, its area is 100. So 400 minus 100 minus 50 minus 100, our final answer will be 150 centimeters square. So 400 minus 100, 300. 300 minus 50, 250. 250 minus 100, 150. So our answer will be 150 centimeter square. That will be the area of the shaded region. This shaded region can be found by subtracting the three white triangles from the total area of the square. And that's how we get the area of shaded region. So answer statement will write, therefore area of shaded region is 150 centimeters square. Let us go to the last sum of this exercise 11.4, question number 11. Question number 11, find the area of quadrilateral ABCD if distance AC is equal to 22 centimeter, distance BM is equal to 3 centimeter, distance DN is equal to 3 centimeter, and line segment BM is perpendicular to line segment AC and line segment DN is perpendicular to line segment AC. This symbol of inverted T is known as perpendicular symbol. That means two sides are forming 90-degree angle. When two line segments form 90-degree angle, this symbol of perpendicular is written in between the two line segments. Line segment BM is perpendicular to line segment AC. That means the angle found between these two line segment is 90 degree. Similarly, line segment DN is perpendicular to line segment AC. That means the angle found between these two line segments, line segment DN and line segment AC, is 90 degree, or a right angle is formed between these two line segments. So perpendicular symbol means a right angle is found between two line segments. Let us check it out in the diagram. Line segment BM, that is this vertical line, line segment BM is perpendicular to line segment AC. AC is the diagonal which is passing through the center of this quadrilateral and joining the two vertices of the quadrilateral A and C. AC is the diagonal which is joining the two opposite vertices A and C of this quadrilateral. This quadrilateral is known as ABCD quadrilateral, quadrilateral ABCD, and AC is the diagonal, and line segment BM is forming a 90-degree angle with the diagonal AC. 90-degree angle means this square symbol will be drawn in the diagram. This square symbol is a mathematical symbol which represents that the angle formed between these two line segment is 90 degree. So whenever the square symbol is there, we have to understand that these two line segments form perfect 90-degree angle or right angle between each other. So similarly, here also there is another square symbol between these two line segments. So we can say DN is perpendicular to line segment AC. So DN is this vertical line, and that DN is a line segment which is perpendicular to the line segment or the diagonal AC. So this perpendicular symbol or 90-degree symbol is drawn in the diagram. So in the diagram, this square symbol is given, which means 90-degree or right angle. But while writing in the notation form or in symbolic form, in a sentence form, we use this inverted T symbol. So children, please remember, inverted T means perpendicular symbol or 90-degree symbol or right angle symbol. So here BM is perpendicular to AC and line segment DN is perpendicular to line segment AC. Again I repeat, line segment BM is perpendicular to line segment AC and line segment DN is perpendicular to line segment AC. So this BM, we can say that is the altitude of this first triangle. We can take this as two triangles which are made when the diagonal AC is drawn through middle of this quadrilateral. So quadrilateral ABCD has a diagonal AC, and this diagonal AC is dividing this quadrilateral into two triangles. The first triangle is triangle ABC, and the second triangle is the triangle ADC. Triangle ADC is the second triangle. So two triangles are formed, triangle ABC and triangle ADC, where BM will be the altitude or the height of this first triangle, because the topmost part of this triangle is point B, and a line segment joining the topmost part of the triangle with a point on the base of the triangle, that the base of the triangle is line segment AC. So we can say AC is the base, and AC is of how many centimeter? It is 22 centimeter. AC is of 22 centimeter. The distance AC is 22 centimeters. So that will take as the base of triangle ABC. Triangle ABC has the base for this triangle ABC. The base is AC, and AC is of length 22 centimeters. So here I have written down the details which are given. For triangle ABC, AC is the base and it is of 22 centimeter. The height will be BM, which is of 3 centimeter. So this will be the height, because it is showing the vertical distance between the topmost point of the triangle and the point lying on the base of the triangle, that is M. M is called the foot of the perpendicular. Here M will be called the foot of the perpendicular. So line segment BM has distance 3 centimeter. So here the distance 3 centimeter is given as the height of the triangle. Similarly, the triangle lying in the second half plane, that is in the bottom half plane of this quadrilateral, is triangle ADC. Triangle ADC, the base will be AC, because if we do this as the inverted figure, then AC will become the base and the point D will come on the top. If we invert this figure, if we do this figure upside down, then AC will be the base and this point D will come here up. So we can say AC is the base and D is the topmost part of the triangle. So here the line segment joining the topmost part of the triangle and a point lying on the base, then that line segment is called the height of the triangle. So DN is called the height of the triangle. So here height DN is 3 centimeter. The height DN is 3 centimeter. Here DN is given. That line segment will be known as the height or the altitude of this triangle ADC, and that is 3 centimeter. And base will be AC, because this whole triangle is supported on this base, that is AC. So base is AC, that is 22 centimeter, height is DN, that is 3 centimeter. So two triangles are given. In order to find the area of this whole quadrilateral, we just have to find the area of the top triangle and the bottom triangle. So if we add the areas of the two triangles, we'll get the area of the whole quadrilateral. So in order to find the area of this whole quadrilateral, we just have to find the area of first triangle, that is triangle ABC, and then we have to find the area of the bottom triangle, that is triangle ADC. So in order to find the area of triangle ABC, we use the formula base into height upon 2, where base is AC and height is BM. The base is AC, that is 22 centimeter, and height is BM, that is 3 centimeters. So instead of AC, we'll substitute the value 22. Instead of the height BM, we'll substitute the value 3. So 22 multiplied by 3, our answer will be 66, and that we have to divide by 2. 66 divided by 2, our answer will be 33 upon 1. Because 66 upon 2, we can cancel and simplify and reduce by using 2's table. 2 1s are 2, 2 33s are 66. Our answer will be 33 upon 1 or only 33. And we'll write the unit as centimeter square, because whenever the area topic is given, we have to write the unit with the power degree 2. So centimeter raised to 2, and we'll read it as centimeter square or square centimeter. So we can say area of triangle ABC is equal to 33 centimeter square. Now we have to find the area of second triangle, that is the bottom triangle, triangle ADC. And the area of triangle ADC can be calculated by using the formula base into height upon 2. Area of triangle ADC can be calculated by using the formula base into height upon 2, where base is AC and height is DN. Base is AC, that is 22 centimeter, height DN, that is 3 centimeter. So we have to substitute the value for base AC, that is 22 centimeter, height is DN, that is 3 centimeter. So we have to multiply 22 into 3 whole upon 2. Our answer will be 66 upon 2. 22 3s are 66. 66 upon 2. 66 upon 2 we can further simplify and write the answer as 33, or we can say 66 half we have to do. Half of 66 is 33, or we can simplify using 2's table. With 2's table we can cancel the denominator 2, 2 ones are 2, and we can cancel the numerator 66, 2 33s are 66. So let me repeat again. 66 upon 2 we can cancel using 2's table. 2 ones are 2, 2 33s are 33 upon 1, or only 33. So we can say the area of this triangle ADC is 33 centimeter square. So here we'll write the unit as square. So we'll read it as square centimeter or centimeter square. 33 square centimeter, or we can read it as 33 centimeter square. After finding the area of these two triangles, triangle ABC's area is 33 centimeter square and triangle ADC's area is 33 centimeter square. Both the triangles are having the same equal area. We just have to add them, and then we'll get the total area of this quadrilateral. The total area of this quadrilateral will be the top triangle's area plus the bottom triangle's area, that is 33 plus 33. Our answer will be 66 centimeter square. Area of quadrilateral ABCD can be calculated by adding the areas of the two triangle. Area of ABCD is equal to area of triangle ABC plus area of triangle ADC. These two triangles will add 33 plus 33. Our answer is 66 centimeter square. So final answer statement will write as, therefore area of quadrilateral ABCD is 66 centimeter square. Let me repeat, children. I have done the steps sideways here. 1, 2, 3, 4, 5 steps I have done sideways. Please remember, in your fair book, notebook, exam paper, answer supplementary or assignment supplementary, please do the sums downwards. All these 5 steps have to be done downwards. First step will be here, the second step will be below the first step, third step will be below the second step, fourth step will be below the third step, and fifth step will be below the fourth step. So all the 5 steps have to be done downwards of this particular paragraph. Similarly, for the second triangle also we have done 1, 2, 3, 4 and 5 steps. 5 equal to signs are there. That means 5 steps are there. These 5 steps have to be done downwards. Similarly, here also there are 3 steps, 1, 2 and 3. All these 3 steps have to be done downwards, and then we have to write the final answer statement. So please remember, children, in your maths paper, in your maths exam paper, in your assignment paper, in your fair book, in your rough book, wherever you do maths, we have to do the steps downwards, because in higher classes, in board exam, 10th board, 12th board, all the maths sums are done downwards, the vertical method of solving the sum. Only for the explanation purpose, to save pages and so that you can see all the steps on your TV screen or on your monitor screen or on your mobile screen, I have done this sums sideways. Please remember this, children. We complete the lesson perimeter and area, and in the next video we'll be starting the lesson simple equations.